Alright, so this video is going to be part 2 of finding the radius and interval of convergence. So we have our power series up on the board here, and we want to find the radius and interval of convergence. Now our power series is the sum from n equals 1 to infinity of -1 to the n plus 1 times x to the n over 5 to the n. Okay, so I wrote a step-by-step process on the board over here, and first we want to see, is this an easily recognizable series, or something that we could make into an easily recognizable series, like with a geometric series, or a p-series, or something like that. Well, actually, yeah, we could do that, so we could even just not do ratio or root test. Now, we could do ratio test to solve this, but it'd be easier to just make this a geometric series. Okay, what we can do, and take the sum from n equals 1 to infinity of, well, if we have a -1 to the n minus 1, right? That's what we want. We want each of these terms to be to the n minus 1. So what do we have to do? Well, if we want an n minus 1, okay, what we have to do is add 2 to n minus 1 to get n plus 1, okay? So what we would do is have that -1 to the second power. Okay, and that will, when they add together, that becomes n plus 1. Now, what about the next one? If we want an x to the n minus 1, well, from n minus 1 to n, you're just adding 1. Okay, you're adding 1, and that gets you from n minus 1 to n. So, we have an x to the first power. Now we put that over, well, we want a 5 to the n minus 1, and that means that we need a 5 to the first power. Put that right out here. And there you go. Now we are one step closer to having our geometric series. Okay, so we have the sum from n equals 1 to infinity of, well, this -1 squared, that's going to go away because that'll just be 1, and we'll have a, well, we'll have a x over 5 times a negative x over 5 to the n minus 1. So this negative x over 5 right here, that's our r. Okay, so that means that for this to be convergent, for this power series to be convergent, we need to have this r in between -1 and 1. Okay, now you can multiply by -1 for each term right here, but then you just get the same exact thing. Okay, because you're not only multiplying by -1, so this becomes a 1, and then you flip the sign, and you get exactly what you have already. And you can try that on your own if you don't believe me. But that's the same thing as saying x over 5 is in between -1 and 1. Okay, so we can multiply by 5 here to get x by itself, and we get -5 is less than x is less than 5. Okay, so there's your interval right there. You have your interval of convergence, and that is from -5 to 5. So now our interval is partly done, but we also need our radius of convergence. And to do that, well, if you're not understanding like the whole concept here, I'll draw it out for you. We have this interval is being centered at 0. Okay, so let's say that this is 0. We go to 5. Let's think of this like a number line. We're going from -5 to 5. And the radius is just half of this. That's 5. Okay? That's your radius. So that your radius of convergence is going to be 5. Okay? It's half of that interval. Alright, so now we need to check these endpoints here, so we need to plug in one at a time into the series. We have the sum from n equals 1 to infinity of, well, -1 to the n plus 1, and we have a -5 to the n, right? We're going to plug in that first endpoint, and that's going to be over 5 to the n. Okay, now we can manipulate this a little bit. This -5 to the n, that's the same thing as -1 to the n times 5 to the n. The sum from n equals 1 to infinity of -1 to the n plus 1 times -1 to the n times 5 to the n over 5 to the n. And these 5 to the n's cancel out. Okay? Now, if you're confused on that, because actually I was kind of confused on how to simplify this at first to get these 5 to the n's to cancel. Okay, this is something we do a lot more often with variables. Okay, so it's kind of weird to see it with numbers. I think that's why I got tripped up. So if you did, here you go. So if you have you can think of this as like an x and a y, okay? And they're to the same power. Let's say x squared times y squared, okay? You're multiplying these two things. That's the same exact thing as x squared y squared, and that's the same exact thing as xy squared, right? So you can put both those numbers, multiply them together, and put them to that same power, okay? And that's exactly what we did here. So that's, it's more common to see that with variables. So I wanted to at least show you that, so you completely understand what's going on here. Now we have a -1 to the n plus 1 times -1 to the n, and all that's telling us is that all of our terms are going to be negative, because this makes all odd terms negative. This is making all even terms negative. Okay, so really you're just adding up an infinite number of -1s, which is divergent. You can even do the test for divergence there, but you can see that this is going to be divergent. Okay, now on to our next one. That's going to be, well, we're testing our second endpoint. That's 5. Now, if we're going to plug in 5 here, we're going to get -1 to the n plus 1 times 5 to the n. That's going to be over 5 to the n. All right. These 5 to the n's are going to cancel, and you're left with -1 to the n plus 1. Now, you can do a test for divergence here. Limit as n approaches infinity of -1 to the n plus 1. And you can see here that each term is either -1 or 1, and that's going to be oscillating on to infinity. So this is obviously not equal to 0 and therefore divergent. Okay, it's not converging to 0. It's just going back and forth between -1 and 1. Well, the terms are on to infinity. Okay, so since they're both divergent, we're not including either of these endpoints, and this is going to be our answer. Okay, we have a radius of convergence of 5, right? Half the interval, that's 5, and our interval of convergence is from -5 to 5, not including both endpoints as we showed here. Okay, so that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for radius and interval of convergence, in the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.